All right, so in the last lesson we looked at how to relate a z-score to an area under a curve using this chart. We are going to be using this chart again today, so if you haven't done it already, go ahead and dig that out. So what we're going to be looking at is just kind of more of the same, but we're going to be looking at word problems and applications of the normal distribution. And remember, the normal distribution is that specific looking curve where we peak in the center, looks like this. Okay, the most likely options are in the center, and the further we go away from the center, the less likely we are. It's called the bell curve. All right, so first let's remind ourselves what z is. So remember, z represents how many standard deviations from the mean we are. So it describes how far out we're going, and the further we go out in a bell curve, the less likely that the values will be far away from the mean. And then recall that the formula for z-score, if we want to find the z-score of x or of a random variable, it's going to be value minus mu, the average, over sigma, the standard deviation. Okay, so we've already said this last time, I think, but let's say it again. Z values below the mean will be negative. And z values that are higher than the mean or above the mean have positive z values. Okay. All right. Also remember that the chart always reads less than a certain z-score, so we're going to have to make adjustments if the problem asks for more than. So let's just get to the first example. Let's say that you have a normal population. And that population has a mean of 20 and a standard deviation of 4. So the first question, maybe before I ask you a question, you can, on all of these, you can go ahead and draw the bell curve once you get the information, right? We know that mu is in the middle. Okay, we know a bell curve peaks in the center and it goes out from there. And then remember, the standard deviation just tells you how far out to go from the center, right? So we'll go out 4, so that'll be 24 and 16. Okay, if we go out a second time, that would be 28 and 12. And if we go out a third time, that would be 32 and 8. Okay, remember we talked about that if we're within one standard deviation, between 16 and 24, we're covering 68% of the data. If we are out 2 standard deviations, or in this case between 12 and 28, we cover 95% of the data. And then if we go out 3, we cover almost all, or 99.7% of the data. But let's say that I ask you for this instead. So I want you to tell me what proportion of the population is less than 18. Okay, so we want less than, but let's go ahead and mark 18. 18 would be here, right? So if I show that kind of with my pencil, that would be basically this area. Okay, it would be the area over here. Okay, I'm going to lightly shade it, but I'll erase it probably in a minute. Okay, notice that this is not a whole number standard deviation away from the mean, so that's why we need the table and we need to find the z-score. So if we want to know how far away 18 is from the mean, we take 18, we subtract 20, and we divide it by the standard deviation. So we end up getting negative 0.5. Okay, that shouldn't surprise you because the value is less than 20, so that's why we get a negative z-score. So you're going to look at the chart. Okay, so just to remind you, remember negative z-scores are on one side, positives are on another side. So we want 0.5, and notice it's 0.5 with nothing after it, so we assume to be 0. So it's going to be this first one, 0.3085. So the proportion we're looking at is going to be 0.3085. Okay, so that would be our answer. Okay. So really the only change so far in what we're doing today is really the fact that we have to find the z-score for ourselves. It's not given to us. So, all right, what about this one? What is the probability that a randomly chosen value will be greater than 25? So first things first, remember in 7.1 we talked about the two things that the area under the curve tells us is the proportion of the population that is less than a number, or also the probability that any random number would be, less than the number. Okay, notice this one is greater than. Okay, so since it's greater than, whatever we get, we're going to need to read the chart kind of backwards or subtract from 1. So first let's find the z-score. So the z-score for x equals 25 looks like value minus average over standard deviation. So you get 1.25. Okay, but just to remember the chart shows less than. So we need to subtract whatever value we get from 1. Okay, so the probability is going to equal 1 minus whatever we read from the chart at 1.25. Okay, so let's go ahead and read that, right? We'll be on the positive side, so find 1.2 first, and then put your finger over till you get to the 0.05 on the top, so it's 0.8944. So if you subtract those, it's 0.1056. Okay. Remember, an alternative is you can also look at the opposite side of the chart and read it as is. So you could look at the opposite z, the negative version. And remember that works because the curve is symmetrical. In other words, it's the same on both sides, so that's why that works. So if you like that better, you can just use the opposite side of the chart. Okay, so let's look at another example. All right, so for some of these word problems, the setup is a little bit long. So this problem is going to be about blood pressure. And we're assuming you don't know a whole lot about blood pressure. So we're going to look at the blood pressures of adult women in the U.S. Typically, anything that's measured, especially like anything with the human body, is usually going to be a normal distribution. In other words, there'll be some mean or average. And the further you get away from that mean or average, it will be less and less likely. So blood pressures are typically normally distributed as long as you have like a group of people. You wouldn't lump men and women together because they have different blood pressure averages. All right, so let's say that all the women in the U.S. have a mean blood pressure of 80.5 with a standard deviation of 9.9. So my first question is, what proportion of U.S. women have blood pressures lower than 70? Okay. So in order to figure that out, we could draw a picture, but we don't really necessarily have to. But if you want to, you can draw a picture of the bell curve for all of these, just to kind of get a taste of what it looks like. But what I really need to do is find the z-score. So z would be 70 minus the average of 80.5 over the 9.9. Okay. You only need to round z-score to 2 decimal places because that's all the chart reads anyway. So we get z equals negative 1.06. So if we look at the chart and find negative 1.0 first and then put our finger over to the 0.6, it looks like it's 0.1446. Notice that this is lower than, so I don't have to do any adjustment. In other words, I don't have to do the 1 minus thing. I can just read the chart as it is. So the proportion equals 0.1446. All right, so what about this question? What proportion of women have blood pressures between 75 and 90? Remember, when you're going between two values, you're going to subtract what you read on the chart. And so you are going to have to find z-scores for both and then look at the chart for both and then subtract what you get. All right, so if we want the z-score for x equals 75, that will look like 75 minus 80.5 over 9.9. Okay, I'm going to let you punch that in the calculator. So if you need to pause the video, then do, but I'm going to have you maybe pause and figure both of these out. The z-score for 90 would be 90 minus 80.5 over 9.9. Okay, make sure you put parentheses around the top when you punch this in the calculator. So again, pause this if you're not sure. But here I get negative 0.56, not surprising, right? 75 is less than the 80.5. And then here I get a positive z-score since it's bigger of 0.96. Okay, so you read the chart and you tell me what the proportion is. So here the proportion is 0.2877. And for 0.96, the proportion is about 0.8315. So if I want the proportion between those two, I'm going to have to subtract. So the proportion of values or blood pressures that fall in the window between 75 and 90 is going to be 0.8315 minus the 0.2877. Remember that this is a probability, so it has to be a probability between 0 and 1. Okay, 0 meaning it can't happen, 1 meaning it can, or that it certainly will happen, and then probably somewhere in between. Okay, so let's look at a few more. So just a little background. A woman with blood pressure with higher than 90 is going to be classified as a person with hypertension. Hypertension's the medical term for high blood pressure. Okay, so my question is, I want you to tell me what proportion of U.S. women have hypertension. In other words, how many have high blood pressure that they probably have to take medicine for? And then my second question for this one is it considered unusual for a random woman to have high blood pressure or hypertension? Remember, our threshold for unusual is 5% or less. Okay, so probably important, we're going to go ahead and underline that we have higher than 90 there. So whatever we read for the z-score, we're going to need to subtract it from 1. So let's find the z-score for x equals 90. So that's going to look like 90 minus the 80.5 over the 9.9. So if you work that out, you're going to get 0.96. Oh, right, we already did that above, right? So we already found the proportion, right? But we're going to need to do 1 minus. So the proportion, since it's more than, is going to be 1 minus what we got up here, which was 0.8315, or 16.85%. Okay. So the question is this unusual? Okay. Notice this is not less than 0.05. Okay. So in other words, this is not unusual. Okay, so it wouldn't be odd or unusual for a woman to have high blood pressure. That's what it means, okay, in the U.S. No surprise there, right? All right, so let's do a percentile problem. We did some of those back in 712. So remember, when I asked you to find the 30th percentile, we're looking for what value would be the high point for 30% of the values. That's what percentile means, okay? So remember that this is actually already giving you the area, okay? So you're going to look at the chart areas, okay, not the z-scores. Okay, so you're going to look at the values in the middle of the chart, okay, these, the ones that are right here, okay? And you're going to try to find the one closest to 0.3 or 0.30. So you want to find the value closest to 0.30, okay? Which if you look at your chart, okay, and again, I'm not going to show this every time, but 0.3, these do go in numeric order. So 0.3, it looks like the one that is going to be on either side of 0.3 are these two, 0.3015 and 0.2981. So you just need to pick the one that's closer. Notice this one's like 0.0019 away, and this one's only 0.0015 away. So it's the 0.3015 that is the closest. But the important thing there is to figure out what z-score that corresponds with. Okay, so that corresponds to a z-score of negative 0.52. Okay, and so now you're going to use this formula. Here is our z-score formula, but this time we know z-score, and what we actually want to know is what this is. We're actually solving for x. Okay, so let's plug in what we know. We know that z-score is negative 0.52. We don't know x, but we do know that the mean is 80.5 and the standard deviation is 9.9. Okay, so for this, you kind of think of this as over 1, and then you're going to cross multiply and set them equal to each other. Essentially what you're going to do is cross multiply these two and add the 80.5 in order to isolate the x. So if you do that, you're going to get x is right around 75.352. Okay, in other words, if you have a blood pressure, if you're a woman in the U.S. and your blood pressure falls around 75.35, you will have a higher blood pressure than 30% of the other women in the U.S. Okay, that's what that means. All right, let's do one more percentile just because there's more to those. So let's find the 67th percentile of blood pressures. Notice the difference between these percentile questions and the ones that we did for test 2 is that we don't have a list of blood pressures, right? In fact, we probably wouldn't in this case, because remember, this is comparing blood pressures of every woman in the U.S., so it's very unlikely we'd have a list of all of that, right? That would be unreasonable. So we look at our chart. So this is just finding out what the value of it would be when maybe we don't have a list, or having the list would be unpractical. The closest value to 0.67 on the chart, if you look, there's actually one that is real close. It's actually 0.6700. That hardly ever happens that you'll get it exact, so you usually just need to pick the one that's closest. And then what you really need to do is say what it corresponds to. So if you look at your chart, that corresponds to Z equals 0.44. And then you're going to plug it in that Z-score formula. So Z-score equals value minus average over standard deviation. And again, you're going to cross multiply and then add that 80.5. And so X would be 84.856. So again, if you're a woman in the US and your blood pressure is around this, then you have a higher blood pressure than 67% of the other women in the US. All right, last question on this one, and then we're going to move on to something else. What if I asked you to find the third quartile of blood pressures? So remember, quartiles, we talked about those when we did box plots back for not chapter 2, but unit 2 on test 2. So you need to remember what third quartile means. Okay, remember the quartiles mean that 25% of the data is split up into each section. And if this is the third one, then what this means is the 75th percentile. So if I would have asked you for the second quartile, it would have been the 50th percentile. If I would have asked you for the first quartile, it would have been the 25th percentile, because 25% of the values fall in each of the quartiles. Okay. And then you just proceed like you did the previous one. So we want to find the closest value to 0.75 on the chart. So always find the two that it's closest to and then decide which of those two is closest. So I think it's closest to 0.7467, which corresponds to a Z value of 0.67. So then finally, if we want to know what that value is, we plug in the formula, right? So Z-score equals value minus average over standard deviation. One more time, we cross multiply and add the 80.5, and so it looks like X would be 87.133. Okay. So once you get past this, you're out of the third quartile is what that means. You would actually be in the highest 25% if you went past this 87.133. Okay, so sometimes the word problems are just kind of about muddling through kind of their lengthy explanations about the situation. So let's look at one that maybe is a little lengthy like that. All right, so let's say the lifetime of a certain type of car tire in thousands of miles is normally distributed with a mean of 40. Remember, it's in thousands of miles, so it's actually a mean of 40,000. And a standard deviation of 5, or 5,000. So I know most of you probably haven't bought tires for yourself yet, okay, but you will someday. And how they sell tires is they let you know on average what kind of miles that tire will get. So for instance, if you buy a 40,000 mile tire, that's a pretty low mileage tire, so it would be a little cheaper than say a 60,000 mile tire, because they're trying to tell you that on average that 60,000 mile tire will last a lot longer than the 40,000 mile tire, okay? But unsurprisingly, not everybody is going to get perfectly 40,000, okay? And in fact, it's actually a normal distribution. So what that would look like is 40,000 would be here, and then some people are going to get less, and some people are going to get more, but the more crazy different from 40,000 you get, that should be less and less likely, if that makes sense. So most people can plan on getting around 40,000, but then it tapers off as you go higher or lower than 40,000. Okay, all right, so for the first question for this one, I want you to find the first quartile for tire lifetimes. Now, if you're in the first quartile, here you're really unhappy, right? If you're in the first quartile, that means you had the lowest tire life, okay, but you paid the same price as everybody else, so you're probably not so happy. So when you see the first quartile, we need to know that that means 25th percentile. So we want to find the closest value to 0.25. So you should have your chart out. If you need to pause as I come up with these, then do, but you should be reading your chart. But the closest thing on the chart is 0.2514, which corresponds to a z-score of negative 0.67. No surprise that it's negative, right? Because the 25th percentile is going to be lower than we expected, or lower than the mean. So then we're going to do negative 0.67 equals value minus average over standard deviation. So same thing we did in the previous problem, just the numbers are a little different. So we would cross multiply and then add the 40, okay? And so here, x equals 36.65. Okay, so let's see if we can kind of write that in a thought or a sentence. So basically the tires with lifetimes in the lowest 25%, since it's the first quartile, will last somewhere less than that benchmark. It will last less than 36,650 miles. In other words, some people are even going to be worse off than 36,650. That's just the end of the first 25%. There's going to be some people that are probably really unhappy and not getting anywhere close to 40,000 miles. All right, so that does happen, by the way. Okay, and so what a lot of times tire companies do is they will offer to give you a partial refund depending on how much basically tire life that you didn't get. So for instance, if you only got half of what you were supposed to get, sometimes they'll give you half of your money back. But sometimes they do like guarantee that you'll get at least a certain amount. It's like, we think you're going to get 40,000, but we're going to guarantee that at the worst case scenario, you'll at least get however much. Okay, so let's say that the tire company wants to make a guarantee like this. It wants to guarantee that it will last a certain number of miles. Now, they're not going to guarantee it for 40. Because the fact of the matter is there's going to be a lot of people that don't quite get 40. Okay, so they're going to have to lower the bar quite a bit if they're going to guarantee. So my question is, what number of miles should the company guarantee so that maybe only 2% of the customers need a refund? So we'll say only 2% of the tires violate the guarantee. Okay, so we haven't done this in a little bit, but if you're doing a problem and you think, I'm not really sure what I need to be doing here, it's always a good idea to kind of sketch your bell curve. My bell curves don't always look perfect, and they don't need to. They just need to be in general kind of the shape that we need. So we know that 40 is the mean, and we know that we're going to go out 5 every time because that's the standard deviation. Okay. So this would be 45, 50, 55, and this is 35, 30, and 25. Okay. So what this problem is asking for is it's asking for like 2%. Okay. It's asking for something here. It's asking where is 2% of the area going to fall. Okay. So basically it's asking us what this value is. Okay, like what is the z-score, and then what is the value that would go with that z-score that would put us at 2% right here. Okay, so in other words, we're going to read the chart at 2%. Okay, so you're going to look on your chart because the chart already reads less than, right? So if we want less than 2%, then that actually works just great. So we're going to look at the chart and see what is closest to 2%, or 0.02. Okay, and the thing that is closest to 0.02 is 0.0202. And that corresponds to z equals negative 2.05. Okay, so then just like we had before, we're going to take that and use that formula for z-score. So it's z-score equals value minus 40, or the mean, over the standard deviation. And so what we're going to get here is 29.75. Okay, so here is the answer then. They should hope that people will get 40,000, but they should guarantee that they'll get at least, make that in thousands, 29,700, 500. What? That is not a word. So 29,750 is what I meant to say. Okay, so they should guarantee that the tires will, at worst case scenario, get 29,750. Now the fact is, some people actually won't get that, but then they would fall in the 2% that are probably going to get refunds. So that's kind of how that would work. Okay, so last example, not everything follows a bell curve. So on most of these word problems, they're going to mention that it's a normal distribution, because frankly, if it's not a normal distribution, or there's not a way to show that it is, you actually can't use the bell curve or the chart that we've been using, the table, to find area under the curve. So that chart is only for things that we can say are normal distribution. So let's say that scores on a statistics final in a large class were normally distributed. That won't always happen, but sometimes in certain classes, grades might follow a bell curve. In other words, most people made in the middle, okay? Very few people did really, really badly, and very few people did very, very well, because the further you get away from that middle, the less likely we are. But let's say that the mean of this test is 75, and the standard deviation is 8. Okay, there are some teachers and professors out there that grade on a bell curve, and I don't usually grade on a bell curve, because what it means is your grade is determined based on how well you did compared to everyone else, instead of just how well you did compared to what the right or wrong answer is. So it's just kind of a matter of preference, but I usually don't grade on a bell curve. But I had professors in college that graded on a bell curve. And it was always really difficult to figure out what your grade was going to be, because it wasn't the traditional, 90% or above is an A, 70% is a C, or anything like that. All right, but let's say that the teacher knows that it's a bell curve, wants to grade on the bell curve, and he wants to give the top 10% of the class an A. And so the question is, what is the minimum score needed for an A? All right, so I don't think that drawing a picture is completely out of the question here, so let's draw us a little bell curve. In the middle is the average of 75, and then we're going out 8 every time. So, I mean, you can fill all this in. I'm not sure we really need to, but this would be 83, right? And then this would be 77. Sorry, 67. The reason I'm not filling this in, though, is because I'm not really sure that I need it. What I want to find out is where is this top 10%? Okay, so I want to find out where is the top 10%. But remember that my chart actually reads this way. Okay, so actually what I really need to talk about is the people that are to the left of that line. And that would be 90% of the class, right? Okay, so we don't look for 0.10, we're actually going to look for 0.9. So you're going to look for the value on the chart closest to 0.9, which in this case is 0.8997. And that corresponds to z equals 1.28. Okay, so we don't want to know the z-score in the end, though. We want to know what the score on the test is. In other words, we want to know what x is. So z equals 1.28, and that's going to be value minus average over standard deviation. And so x is going to be whatever you get when you cross multiply and add 75. So it looks like 85.24. So rather than the limit for A being a 90, as it traditionally would be if you did not grade on a bell curve, it looks like anything higher than 85.24 would be an A. Okay, so anything higher is an A. Actually, anything that's higher than or equal to that is an A. Okay, so an 85 wouldn't quite cut it. You'd be a little disappointed if you got an 85 because it wouldn't quite be what it needed to be. Okay, so last part to this one. So between what two values are the middle 60% of the scores? Okay, so we haven't really done one like this before. Maybe we did in 7-1, I don't really remember. But what we're going to do is if we're a little unsure, we're going to come up with a picture for ourselves. Okay, so I think there's too much writing in the one up above, so I'm going to sketch another one. Shouldn't take us that long anyway. So 75 is where we think we're going to be. That's the center. And so it's asking you to bound or figure out what the middle 60% is. Okay, so from here to here, we're at 60%. Okay. So if we're at 60% from there, that means outside of that 60% would be 40% total, right? Which actually means that this is 20% and this is 20%. Okay. And remember that we're actually trying to find these z-scores, okay, so that we can translate those into x values, okay? So we actually are going to need two values, but notice because this is symmetrical, we can look at the positive or the negative. We actually want both, okay? So what we're going to do is we're going to look for the negative z-score. And then once we find that, we also know that the positive one would apply to. Okay, and we're going to want to look at the chart, and then you need to decide what value you want. Remember, it reads less than, so we actually need to look here. So we actually need to look at the chart at 0.2 or 0.20. So you want to look for the value on the chart closest to 0.20 or 0.2. Which looks like there's one that's 0.2005, and that corresponds to z equals 0.84. Okay, so this is the z-score, right? The z-score here is 0, so it looks like this has a z-score of 0.84. Sorry, negative. Okay, those should all be negative, which means the positive one has to be the same number, just in the positive direction. So that means this one has to be positive. So on the other side is z equals 0.84 positive. All right, so let's see if we can figure this out. So we're going to have two values here. So we're going to say negative 0.84 equals what minus average over standard deviation. But we're also going to have the positive version. Because what we want is we actually want to know what the x values are there and there. Okay, and so if you cross multiply, you're going to get x equals 68.28 here. And here you're going to get 81.72. Okay, so if we want to bound the middle 60%, it will be between these two scores. 68.28 and the 81.72. Okay, so all we're kind of doing is learning how to read this chart and learning how to find the things that we need to read this chart. Learning how to find the area if we know the z-score. Learning how to find the z-score if we know the area, and all the things in between. Okay, so definitely keep this chart handy for lessons 7.1 and 7.2, and go ahead and try to begin the homework on those sections.